Numerous innovations in technology are fast advancing the world of construction materials, bringing new products to market that could make a big difference to our built environment. Here we take a look at 3 particularly impressive developments. Whilst cement is one of the most widely used materials in construction for its strength and durability properties, it can crack when exposed to water or chemicals over time, undermining structures. A research team at the University of Bath in the UK are now developing a form of self-healing concrete by adding microcapsules to mixes that contain calcite precipitating bacteria. When water enters cracks in the concrete, these bacteria germinate to produce limestone, filling the cracks and preventing any steel reinforcement from corroding due to prolonged exposure. If scaled and applied effectively, this self-healing solution could extend the life of concrete structures and reduce maintenance costs. Kinetic paving is a new concept that harvests energy from the footsteps of pedestrians moving around a building or a public space and converts the energy into electricity. A UK-based startup called PaveGen have developed the energy harvesting paving slabs made almost entirely from recycled tyres. The slabs flex 5mm when stepped on, generating 8 watts of kinetic energy. Each tile has its own wireless transmitter that uses 1% of its power to store and send data on its performance to a central database. The tiles can be installed on a permanent basis or temporarily at events. They were used on a main thoroughfare in the London 2012 Olympic Park, on a portion of the Paris Marathon, and under a football pitch in Rio de Janeiro, powering the floodlights. The key to success with this technology is of course traffic volume. PaveGen estimated some 12 million steps fell onto their tiles during the London 2012 Games, generating 20 kilowatt hours of electricity. In a nutshell, 4D printing refers to 3D printed objects that have the ability to reshape or self-assemble over time. Now, we recognise that's quite a complicated nutshell to get your head around, so here's a bit more detail. 4D printing was born out of a self-assembly lab established by Skylar Tibbets at the Massachusetts Institute of Technology, or MIT. It was a concept he developed alongside Stratasys and Autodesk. It involves strategically positioning rigid and expandable materials next to each other within one 3D printed component. When the expandable materials come into contact with water, they grow up to 200% of their original volume, changing their shape and effectively repositioning the rigid materials either side of them. The expandable materials effectively create joints in the components that are activated in certain conditions, causing the entire component to adopt a different form. Depending on the expandable material used, the contact substance necessary for it to change shape could be water, or it could be heat, light, or a range of other simple energy inputs. Software enables components to be programmed on screen before they are created, and for that data to have effectively been programmed into the component once it's been created. Going beyond this range of small-scale demonstration pieces, it's thought the technology could be used in some form of self-repairing water pipes, in pipework that changes size in relation to water flow, or in hot and cold temperature water valves. Beyond plumbing, it also has potential in medicine, clothing and footwear that adapts to climatic conditions, or in childcare products that respond to temperature changes. If you enjoyed this video and would like to get more from the definitive video channel for construction, subscribe to the B1M.